Hi all, welcome back to myclass.com. Our topic, bubble sort, one of the simplest sorting algorithm. Let's start. Bubble sort is a simple sorting algorithm. This sorting algorithm is comparison based algorithm in which each pair of adjacent elements is compared and the elements are swapped if they are not in order. We are comparing adjacent pair of elements and if required, swapping will work. If they are not in an order, the elements will be swapped. That is a technique of bubble sort. This algorithm is not suitable for large data sets. It is a very simple sorting algorithm, but when we are using it for a very large data set, it will take long time because its average and worst case complexity is order of n square, and it is order of n square where n is the number of items. How we will get the order of n square, that I will explain at the time of algorithm analysis. How does the name bubble sort come? Just like the movement of air bubbles in the water that rise up to the surface. Each element of the array move to the end in each iteration. So in each iteration, last element should be in the correct order. That is, each element of the array moved to the end in each iteration, that is in the correct place. Because of that, we are called it as bubble sort. Bubble, just like a movement of air bubble in water. So let's discuss bubble sort algorithm. Here I am taking an example with value n equal to 7. Okay, this algorithm is for working with an array name A and total number of elements is n. In bubble sort algorithm, there are two different loops, one outer loop and one inner loop. The outer loop is working from k to 0 to n minus 1. N minus 1, that is, in particular example, it is 0 to 6. 0 to 6 means the k less than 6. The loop is working up to k less than 6. So the values of k varies from 0 to 5. So in this particular example, the outer loop works how many times? 6 times. This outer loop iteration we are called passes. Okay. So in bubble sort, n minus 1 passes will be therefore in bubble sort algorithm. Okay, n minus 1 passes where n is the total number of input elements in the array, in the data structure. Okay, so in each iteration of the outer loop, we are doing the step 2 and 3. Step 2 and 3. Okay, I have already told that 0 to 5 is the values of k varies from 0 to up to 5. So at the first pass, that is k equal to 0, first we are set ptr equal to 0. ptr equal to 0. Okay, in each iteration of outer loop, we are comparing each adjacent pair of our array and moving the very greatest element. This algorithm is for sorting in an increasing manner. So after each pass of each iteration of the outer loop, the biggest element should be in the last place. So in k equal to 0, at the time of k equal to 0, we are setting ptr equal to 0. Then we are starting the inner loop, that is up to ptr less than n minus k minus 1. So always the inner loop is connected with the inner loop is working according to the value of k. So this first pass is in the inner loop working of the first pass will be up to, in this particular example, 7 minus 0 minus 1, that is 6. So the inner loop working up to 6, that is 0 to 5. So in this inner loop, what we have checking? We are checking that a of ptr, if a of ptr greater than ptr plus 1. Our ptr value is up to 0 to 5. So first we are checking a of 0 greater than a of 0 plus 1, that is a of 1. A of 0 greater than a of 1 or not. If it is like that, we are interchanging. Otherwise, we are doing nothing. So in this particular example, there is a swapping is there because 56 is greater than 45. So we are swapping. Then we are incrementing the PTR value. So at that time the PTR value should be 1. Then we are checking A of PTR and A of PTR plus 1, 45 and 98. Then if interchange is required, we are exchanging this value. Like that the algorithm is work. So after the first pass, that is k equal to 0, our biggest element should be in the correct place, in the very last place. Then we are going to the next pass, that is k equal to 1. When k equal to 0, we are working 6 times. Inner loop is working 6 times. When k equal to 1, the inner loop is working like PTR less than n minus k minus 1. N minus k minus 1. In particular example, 7 minus 1 minus 1, that is 5. So 5 means 0 PTR. 5 means PTR up to less than 5. That is 0, 1, 2, 3, 4. That is 5 times itself. Okay, 5 times only. When the second pass, that is k equal to 1, the inner loop is working 5 times. Like that, working of the inner loop will decrease, because in the first iteration of the outer loop, the biggest element should be in the correct place. Then no need to compare that element with others. So we are avoiding that biggest element. Because of that, the algorithm only compare 5 times in the second iteration, second pass. So in the third pass, it should be 4. When k equal to 2, it is 4 times. When k equal to 3, it is 3 times. When k equal to 4, it is 2 times. And k equal to 5, it is 1 time. After the working of all the passes, when we are checking the array should be in the sorted order. So that is the working of bubble sort. Okay, so repeat step 2 and 3 for k equal to 0 to n minus 1. In each iteration of the outer loop, we are doing set PTR equal to 0, then PTR, repeat another loop, that is PTR less than n minus k minus 1, and we are checking each adjacent pair like a of PTR greater than a of PTR plus 1, then we are interchanging, otherwise we are doing nothing. Then we are incrementing the PTR value, then we are comparing another two adjacent pair. Like that we are doing. After the working of the inner loop, we are exiting from the inner loop and doing the another pass, another iteration. So after the full working of outer loop, we are exiting from the algorithm. At that time we will get a sorted array element. Okay, hope it is clear now. So after the explanation of the algorithm, we can say that a bubble sort algorithm contains n minus 1 passes. N minus 1 passes, and each passes we are doing n minus k minus 1 inner loop work. Okay, now we will explain with an example. So this is our pass 1. Pass 1 is k equal to 0. So the inner loop is working up to PTR less than, here n equal to 7. 7 minus 0 minus 1 PTR less than 6. That is 6 times it is working. The inner loop is working 6 times up from 0 to 5. PTR value equal to 0 to 5. So we are checking like first a of 0. We are checking with a of 0 and a of 1. A of 0 is greater than a of 1. So we are exchanging. We are swapping this value. Next inner loop working. We are compare with a of 1 and 2. A of 1 and a of 2. So there is no need of interchanging because a of 2 is greater. Like that we are doing all the 6 inner loop work. Now we are checking 98 and 66. We are interchanging. Now 98 and 47, here also we are exchanging. Here 98 and 32, here also we are swapping. Now 98 and 47, this is the last inner loop working up to 5. Okay, so we are working a of 5 greater than a of 5 plus 1, that is 6. If it is true, we are exchanging. So after the working of all the inner loop iteration, our biggest element should be in the very last place. So that is the pass 1. In pass 2 means value of k equal to 1 and so it is the inner loop is working up to PTR less than 7 n minus 1 minus 1, the 7 minus 1 PTR less than 5, that is up to 0 to 4. 5 times working. So here 5 times only working because we does not need to compare this value because this is in the correct place now. We are comparing with this, like we are comparing the adjacent pairs, and if swapping requires, swapping will do. Okay, like that. Here there is no need of side swapping. Here also there is no need of swapping. Here 66 and 47, so 66 is greater, so swapping requires. After that 66 and 32, so here also swapping requires. Here also swapping requires. After the working of all 5 time iteration of the inner loop, the 66, the next biggest element is in the correct position. Okay, so it is the pass 2. In pass 3 also, pass 3 means value of k is 2. So the inner loop is working up to 7 minus 2 minus 1, that is PTR less than 7 minus 3, 4. So 4 times our inner loop working. We are comparing this to first and no need of swapping. Here we are comparing this. So there is swapping requires. So 47 is here and 56 is here now. We are comparing 56 and 32. So 32 will be here now. Now we are comparing 56 and 47. So 56 is the biggest value. So we are swapping it into this position. Okay. So after that, this 3 portion is in the sorted order and the remaining portion, this up to the index 3 is the unsorted portion after pass 3. After pass 4, when k equal to 3, our PTR is working with 7 minus 3 minus 1. PTR less than 7 minus 4 is 3. 3 times it is working. The value of PTR like 0, 1 and 2. So we are comparing this adjacent pair and this adjacent pairs. So there is no need of swapping here. Here one swapping requires. Here also there is no need of swapping. So at that time this 4 portion, the 47 is in the correct place now. Okay. Now in the pass 5, k equal to pass 5 means our value of k is 4. So we are working PTR less than 7 minus 4 minus 1. So PTR less than 2. So 2 times. The inner loop is working 2 times. So we are comparing this 2 and this 2. So here 32 is smaller. So we are swapping into this position. We are comparing next 45 and 47. There is no need of swapping. See, after that our array is this much portion is in the sorted order. Only we want to check this 2. Actually it is in the sorted order, but we want to do one more step also because we are doing n minus 1 passes. So after the last pass, k equal to 5, that is the last pass. So in this, the PTR is, the inner loop is working up to n minus k minus 1. So that is 7 minus 5 minus 1. That is 7 minus 6 is 1. So only one time the inner loop is working. That is we are checking only a of 0 greater than a of 1. Okay, it is less than, so there is no need of interchanging. Okay, so after the pass 6, the elements should be in the sorted order. So when we are explaining with an example, we can easily understood that there is no need of extra space for sorting. Only we are using a simple variable for exchanging this 2 value. For swapping, we all know that there is one variable requires for swapping 2 numbers. Is it? So only that variable is required for bubble sort. Because of that, we can say that it is an in-place sorting. Bubble sort is an in-place sorting. One more thing is that, so there are 2 47s are there. So this was our first 47 and this was our second 47. This is in the same order after the sorting also. Because of that, we can also say that it is a stable sorting. So bubble sort is an in-place sorting and also stable sorting. Now we are analyzing bubble sort code. Let's assume that. So this was our major portion, that function of bubble sort. The outer loop is working up to, for I equal to 0, I less than n minus 1. So it is working n minus 1 times. Okay. So in particular example, it is working 6 times. 6 times, that is 6 passes are there. 6 passes are there. So in each iteration of the outer loop, the inner loop is working up to 0 to n minus I minus 1. N minus I minus 1. At each inner loop, we are checking the adjacent pair of values, and if requires, we are swapping the values. So only we are using an extra memory for a temp variable. That is, we are called a bubble sort as in place algorithm. So let's assume that in this particular example, the outer loop is working 6 times. Okay. 6 passes are there, like k value 0, 1, 2, 3, 4 and 5. So in first pass, when k equal to 1, it is working 6 times. The inner loop is working 6 times. That is n minus 1 time. When k equal to 1, it is working 5 times. That is n minus 2 times. Okay. How much working is there, that we are going to check now. In the third pass, that is k equal to 2, this is working 4 times. Is it? 4 times means we can write like n minus 3. So like that, we can generalize our situation. So in the fourth pass, we are doing like n minus 4. We can write like n minus 4 like that. So at the last pass we are only inner loop is working one time, and here the fifth pass it is only working 2 times. So it is, we can generalize like this. Okay, it's like a mathematical series. We can write like that: n minus 1 plus n minus 2 plus n minus 3 etc. after plus 2 plus 1. After the all passes we can generalize our all working like this. So this is a summation series of natural numbers up to n minus 1. Is it 1 plus 2 plus 3 plus up to n minus 1? The solution of the summation series is, we can write n into n minus 1 by 2. That is n square minus n by 2. We can write n by 2 minus n by 2. So for the complexity analysis, we are only taking the exponential, high exponential term. So we can write that our worst case complexity is order of n square. What should be the worst case? If we want to sort the array in an increasing order and it is decreasing orderly, it is sorted. That is the very worst case, is it? So at that time, all 6 passes are required, and in all 6 passes, all values should be swapped. Okay. What should be the best case? We want to sort in an increasing order and our array already in an increasing order. That is the very best case. Is it? How can we understood this array is in a sorted order? In this code, we cannot understand, because when we are starting the loop, all the inner loop and outer loop works completely. But after one pass, we can recognize that is the array already in a sorting order. Let's explain. Let's assume that we have setting a flag here. It's an integer variable, flag equal to 0. After the working of pass 1, okay, after the first iteration of our outer loop, we are exchanging this, we are comparing this value. Is it? When we are comparing, all the values are in the correct order. This if does not works. Is it? So if the if was working, we are updating the flag value inside our if structure. Flag equal to 1. If all the elements are in an increasing order already, this if structure does not going to work. If it is not working, our flag does not update its value to 1. Okay, so after the first working of the inner loop, if we are checking like that, if flag is still the value is 0, we can break from our outer loop and we can print like we can exit from this bubble sort function. So in this case, in this particular case, we are only working our pass 1. Pass 1, the first iteration of the outer loop. In the first iteration of the outer loop, the inner loop is working only n minus 1 times. The n term is on n term with the exponential power 1. So we can say that our best case complexity of bubble sort is order of n. Okay. We are getting order of n only because of we are changing our code little bit by using a flag variable. So our best case is order of n and our worst case is order of n square. So our average case also order of n square. Okay, when we are taking the average n square plus n by 2, at that time also we are only taking the biggest term. So the average case also order of n square. Okay. So that is all about our bubble sort algorithm analysis. Hope it is clear now. Thank you.